Hello everyone and welcome back to the Nerd Cave. In today's tutorial, we're gonna look at how to connect this 5V relay to the Raspberry Pi Pico. Before we start this video, I first want to say thank you to all that have subscribed, making us reach the first YouTube milestone, which is 100 subscribers. So the next milestone will be that 1000 subscribers. One of the most useful things you can do with the Pico is to control higher voltages, especially AC voltage in a typical range depending on your location of 120 to 240 volt in appliances like fans, lights and other household appliances. Since the Pico can only deliver a maximum voltage at 5V and limited current, it can control these devices directly. But you can use a 5V relay to switch 120 to 240 volt up to 10 amperes using the Pico with a 5V relay. We will first look at controlling this LED light lamp base, using a relay and a Pico to turn it on and off every 5 seconds. Then we end the video by using a photoresistor to turn on the LED light base when the resistance is a specific value, acting like a day-night switch. A day-night switch switches outdoor lighting on and off automatically. It consists of a light-sensitive element that registers the ambient light. In this case, we are using this photoresistor. The relay will close and turn on the light bulb if we reach a preset value of resistance, measured by our Pico through the analog to digital converter. Just a warning before we start. This tutorial involves high voltages that can cause serious injury or death. Please take all the necessary precautions and turn off all the power to a circuit breaker before working on it. In this tutorial, I'll use the SRD 5V SL-C 5V relay because it's a very popular among the Arduino and DIY electronics hobbyists. Let's start with seeing how the 5V relay works, then I'll show you how to set it up with the Pico and give you some code to get it working. The relay has 3 high voltages terminal, normally closed, common, and normally open, which connect the devices you want to control. The other side has 3 low voltage pins, ground, VCC and signal, which connect to the Pico. Inside the relay is a 120 to 240 volt switch that is connected to an electromagnet. When the relay receives a high signal at the signal pin, the electromagnet becomes charged and moves the contacts of the switch open or closed. So let's take a look at what is meant by normally open versus normally closed. The one you will use depends on whether you want a 3.3 volt signal to turn on the switch or turn the switch off. The 120 to 240 volt supply current enters the relay at the common terminal in both configurations. To use the normally open contacts, use the NO terminal, and to use the normally closed contacts, you use the NC terminal. When the relay receives a high signal in a normally open configuration, the 120 to 240 volt switch is closed and allows current to flow from the common terminal to the normal open terminal. So if you want a high signal to turn on the relay, use the normally open terminal. Now when we use the normally closed, a high signal opens the switch in the normally closed configuration and interrupts the 120 to 240 volt current. A low signal will close the switch and allow the current to flow from the common terminal to the normally closed terminal. Therefore, if you want to use the high signal to turn off the 120 to 240 volt current, use the normally closed terminal. For this tutorial, we will use the normally open configuration. Let's look at the schematic diagram. The relay module has a plus, where you will connect the 5V from the Pico's 5V output and the module's ground to any ground pin on the Pico. For the signal pin labeled S, I will use GP18, which is pin 24, but you can use any other GP pin on the Pico. We will connect one end of the blue wire, which is your neutral, to common, and the other end of the split we did to normally closed for the load. Now it is time to code and control the relay. Open Phony and create a new file. From machine we will import pin and import the utime library for delay. We will create a variable relay and set it equal to pin 18, making it a pin out. Then we create an endless loop by saying while true, and we set the relay value to 1, sending a high signal, closing the contacts, allowing the lamp to turn on. We then wait 5 seconds using the sleep function and set the signal being sent to the relay to 0, opening the relay contacts, turning off the lamp, and wait another 5 seconds before we repeat this whole block of code. That is in short how we control the relay module. Now let's look at something more practical. We are going to add a light dependent resistor to our circuit. A photoresistor or light dependent resistor, and LDR for short, is an electronic component that is sensitive to light. When the light falls upon it, then the resistance changes. To make the changes to our schematic, we will connect the one leg of the LDR to the 5V rail and the other leg to pin 34, which is our analog to digital converter channel 2. And from that leg, 100 kilo ohm to ground. Now from our machine library, we will also import ADC. Then we create a variable called LDR and we will put it equal to the ADC pin 28, which is our channel number 2. Then in our main loop, we will create a variable called reading the 16-bit value of our LDR. Then we print out that reading and we do a short delay of 0.2. Now you're gonna have to play around with the values you are reading, because there is different types of LDR that has different type of resistance. That is why we are printing out a reading. We see that if the light is on, we're getting a value about 5000, and when I put my hand over the LDR or create a shadow, the value drops below 3000. So I'm just gonna create an if statement. If reading is smaller than 3000, we're gonna set the relay value to 1. Else if the reading value is greater than 5000, we will set the relay value to 0, turning off the light. We can see the relay works as we would expect. Now that you know how the relay works, go and use it in your project and share it here in the comments as I would like to see. That is all for the tutorial today, and if you have any questions, just leave a comment down below.